You mean the test based on the quiz, practice quiz from yesterday? If we do one, it'll be next week. I think Mr. Erickson's decided to forego that quiz because we're still behind. So we're going to keep rolling. Okay? Now, with that being said, we've talked a lot about logarithms so far, right? Now we're going to be able to start figuring out other ways to manipulate logarithms to help us solve equations, okay? So I want to, first of all, on this opening exercise, we want to start by converting the following logarithmic equations to equivalent exponential expressions. So what does that mean in English? Does anybody guess what that means in English? What do you think, Zach?
Like log your times what power, she's got to write it as the number to that power.
Okay, so what's the base of this logarithm then? This is base 10, right? So if I write an exponential expression that's equivalent to this, it'll be 10 to what power? 10 to the fourth power equals 10,000. Is that an accurate statement? Yeah, it is. So this is 10 to the fourth power equals 10,000. All right? I get log base 10 of the square root of 10 equals 1/2. What would be an equivalent log or equivalent exponential expression for that? Again, what's the base of this logarithm right here? Base of this logarithm is 10, so the base of my exponential expression is also going to be 10. 10 to what power equals the square root of 10? Well, 10 to the 1/2 power equals the square root of, not the square root of 2, the square root of 10. Okay? I want the class to do C through F. Do C through F. And I'll be going around class checking your work. Who's got some input for letter C? Cora. Hey, Nick. What about letter C, Cora? You didn't get letter C? Did you get another one down the road? I'm coming back to you then. All right. Jesse, letter C. What'd you get? 2 to the 8th power equals 256. What tool do we use to help us in answering questions like this? Calculator. I saw you punching stuff into the calculator, right? And how many times did you have to try in order to get that? You have to do one time for that one? How about for this one? You have to try 0 times? Is that because you left it blank? So you came to the right answer. So you at least tried once, right? It is a pattern. Absolutely it's a pattern. What is the pattern? Who remembers log roll? The log roll, 2 to the 8th power equals 256, right? 4 to the 4th power equals 256. So 4 to the 4th power equals 256. Did I take your time to shine away, Cora, by answering this one? Okay. What about letter E? This is kind of different, right? This breaks the pattern a little bit. What is the base of natural log, first of all? E, right? So E to what power? E to the 0 power equals 1. And then we're back to normal or common logs again. So what's this one? Who got this last one? Kaya, go ahead and lay it on me. So this is the logarithm rewritten in exponential form, right? And Kaya went one further. She realized that 10 to the third is just a fancy way of writing 1,000, which equals x plus 2. And then she went one step further and subtracted 2 from each side. And then we said x equals 998. So Kaya even went this step and solved for x. So we would call that going above and beyond, right? Good on you. Okay. Yeah, is that going to help you on test day, though, Nick? Not exactly. So, with that being said, so Kaya kind of gave you the blueprint here. Kaya kind of gave you the blueprint. Don't use photo math. Use your log roll. Do example 1. Do example 1. Mr. Hay. Hi. Yeah, I'll tell you what. Pop a paperclip on it. That'll be fine. Better yet, put it on my computer so I don't forget about it. All right, so. Okay, you don't want to do this? You don't want to do this? That's. We're on this guy right. If you don't want to do it, that's fine, but I need you to quit distracting this guy. You focus. You are now. I was. Don't forget to solve for x in this one. Yeah. Or you can do the log roll, right? E to what power gets you e to the fourth? E to what power gets you e to the fourth power? Yeah, right? E to, you can do that for this one, but not for this one, right? Now you have to punch in natural log of 6. All right. Nick, give me the exponential equivalent to this expression. Do your log roll and give me an expression with exponents. Nice, Nick. I forgot there's Nick and there's Nick. I was looking at Arizona State Nick, but I got an answer from Nike Nick. I'm cool with that. All right, Nick Swanson. 10 to the 0 is a fancy way of writing what number? 1. So 1 equals 3x plus 7. And when I solve for x, I get what? Go ahead, Cam. Okay. Negative 7/3. Minus 7, or no, negative 6 equals 3x. So x equals negative 2. Negative 2. All right. So, number 2. Log roll, right? 2 to the 4th power equals... Yeah, 2 to the 4th power equals x plus 5. 2 to the 4th power is a fancy way of writing what number? 16, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 equals x plus 5. So x equals 11. This one's a little trickier. This one's trickier. What do I have to do first before I do log roll? Yes. Yeah, so Caleb said if I'm adding 2 logs, I multiply them. Be more specific though. This is going to be the log of what? Yeah. X plus 2 times x plus 5. And that all equals 1. Now can I do my log roll? Now can I do my log roll? Could I do my log roll before, Trey? Why not? It was 2 logs, right? Can't do 2 logs. I got to do 1 log. Okay? So now, do the log roll, and I get what? 10 to the first power equals that hot garbage, right? 10 to the 1 equals, should I multiply them now or multiply them later? Or should I multiply them at all? Multiply them now. I agree. Let's multiply them now. So I get, what is that? X squared, right? X squared plus 2x plus 5x, that's plus 7x, and then plus 10. Can I subtract 10 from both sides? Make that 0? I don't want to do that. How do I solve quadratics? This is a quadratic equation, is it not? How do I solve quadratics? Gotta set make it equal to 0, right? So I gotta get rid of this guy. I gotta get rid of this guy. So I 10 to the 1, fancy way of writing 10. 10 to the 0 is 1. So I subtract 10 from both sides. So whap and whap. So I get 0 equals x squared plus 7x. Now what? You separate it. It starts with an F. Yeah, factor. Good, good. So, what does, I got only 2 terms here, right? So all I need to do is I need to figure out, does x squared and 7x have anything in common between them? It's got an x in there, right? So I can take an x out. Well, x times something gets me x squared. What is that something? X. And x times something gets me 7x. What is that something? 7. And that all equals 0. Now, if I got those 2 things equal to 0, what does that mean about this something or that something? They got, one of them's got to equal 0, right? Can they both equal 0 at the same time? Not in this particular case, right? So then I get 2 statements. I get x equals 0 or x plus 7 equals 0. And then I solve for x, right? This one's already solved. What's this x? Yeah, so I subtract 7 from both sides, I get x equals negative 7. And those are my 2 answers. What time do we got till today? 80? All right. What's that? Why not?
I mean, if you want me to.
Is it bothersome? I don't know. Let's do one more. Yeah, it's a quick thing. All right, we're going to skip exercise 1. And we are going to do exercise 2. Exercise 2. What's the base on natural logarithm again, ladies and gentlemen? E. So e to the what power? 15th power. E to the 15th power equals 4x all to the 5th power. Now, Riddle me this. 4x all to the 5th power. Why didn't I just write, why didn't they just write it like that?
That's just an X.
Yeah. Yes. Excellent, Michaela. When I write it this way, this is 4x times 4x times 4x times 4x times 4x. How many times? 5 times. What's this? This is 4 times x times x times x times x. I'm running out of room, but times x. Okay, so this guy equals 4 to the 5th power times x to the 5th power, right? And that all equals e to the 15th. Did I just unplug my thingamabob? Oh well. I did too. So, can I simplify this? What is 4 to the 5th power? 1024. Good. So then I can get rid of that by doing that on both sides, right? So then x to the 5th equals, I don't even need to do that though, because check this out. E to the 15th over 4 to the 5th. We're not using a random letter. E is a very specific number. And we use E because it is the base of the natural logarithm.
Well, tell me which letter to use, or if it always.
E is a number. E is 2.7128112 something something something. It's kind of like pi in the sense that it's a special number, but it's different than pi. Anyhow, I digress. How do I solve for x to the 5th? Or how do I solve for x? Can I take the 5th root? What's another way of looking at that, Anthony? To what power? Not negative 1/5.
No,
The 1/5 power. I'm sorry, I thought I heard that. So I'm going to take both sides to the 1/5 power. Nick? Hi. I take a power to a power. What do I do to the exponents? I haven't given you your, if I do x to the a power, all to the b power, what does this equal? X to the ab power, right? So I multiply the exponents. I multiply the exponents here. So this is going to equal, e to the 15th times 1/5, and this is going to be over 4 to the 5th times 1/5. This is beautiful. This is beautiful. Because what happens to the 15th and the 1/5? What's 15 times 1/5? 3. So this equals e cubed. And then 4 to the 5th times 1/5. What's 1/5 times 5? 1. So this is just 4. Can I simplify this any more? I could punch in the number for e and cube it and then divide it by 4, but I prefer this. That's what x equals, right? X equals e cubed over 4. All right. So your assignment for, I can't believe this is the whole assignment. I reserve the right to add more to this assignment, but we'll make this assignment due on Friday. 3 and 4. I find it hard to believe I'm not assigning any more, but there we have it.